Today we're going to talk about the factored form. Now remember we had the big picture. Quadratics can be written in three different ways. We talked about the vertex form and how this was excellent for us to find the vertex. And when we went from vertex form to standard form, we simply expanded. And similarly, when we go from from factored form to standard form, we also expand. We also talked about how going from standard form to factored form was factoring, and from standard form to vertex form, we have two different ways to do this. We have the method of using h is equal to negative b over 2a. Alternatively, you could use the completing the square method. Today we're going to look at the factored form and see how we can go from the factored form back into the vertex form. Now let's recall the critical points that we have. We have our x-intercepts, and for every x-intercept, we have a y-coordinate of 0. So we could say we have x-intercepts. I'll call one s, and I'll call the other one r, where s and r are numbers. We also have a y-intercept. The y-intercept always has an x value of 0. And finally, we have a vertex. The vertex is closely related to the axis of symmetry because our axis of symmetry is always equal to the h value. So let's recall the factored form. We have y is equal to a bracket x minus s times x minus t. So sometimes I've used r, sometimes I've used t. It doesn't really matter. These letters are just to represent that it's a constant, meaning it's a number. So how do we know that this is quadratic? Remember we said that quadratics always have to have an x squared. But when you look at this equation, it doesn't look like it is an x squared. But upon closer inspection, if we were to expand this, the first thing we would do, we would take our x and we multiply our x. So our next row, we would have a times x squared, and it goes on. Now, once we know that we have an x squared in our equation, then this must be a quadratic. A is also the same in all of the forms. So the factored form will tell us the x-intercepts. We've already said that all x-intercepts have y is equal to 0. So let's find the x-intercept in this equation. We're going to substitute y is equal to 0 into the equation. 0 is equal to x minus 3 times x plus 4. Now we know that 0, when multiplied, is very powerful because anything multiplied by 0 will give you 0. So what that means for us in this case is if I can create one bracket to equal 0 or the other bracket to equal 0, then this equation can be satisfied. So I have x minus 3 is equal to 0. And when I solve, I have x is equal to positive 3. Our second bracket, x plus 4 is equal to 0. When I rearrange, x is equal to negative 4. And we have our two solutions. We've got two answers for how this works. So if we ever were to substitute it in, let's just demonstrate. Substitute x is equal to 3 into the equation. I have 3 minus 3 times 3 plus 4. Now I have 0 times 7, and that equals 0. So even though the second bracket isn't equal to 0 when I substitute x is equal to 3 in, the first bracket is, and that's enough for me to have a final answer of 0. Let's do it for the other one, just to prove it. When I substitute x is equal to negative 4 into the equation, I would have negative 4 minus 3 times negative 4 plus 4. So that equals negative 7 times 0. And negative 7 times 0 also gives me 0. So this one has given us two answers. And each of these answers are the x-intercepts. So my first coordinate of the x-intercept, 3 and 0. Second coordinate of the x-intercept is negative 4 and 0. So in general, we're making each bracket equal to 0, solve for the x, and we have our intercepts. So other things that you might hear instead of saying the word x-intercept is you might hear look for the roots of the quadratic. You might hear something like the zeros of the function, or you might hear solve the equation. These are all synonyms for saying find the x-intercept. So the conclusion we have for finding the x-intercept in factored form, make each bracket equal to 0, solve for the x, and those are the x-intercepts. Now sometimes we have a different number of x-intercepts. So a parabola can have 2, 1, or 0 intercepts. So let's look at the first case. This is the one that we're familiar with. We have a parabola. Oops. We have a parabola that touches the x-axis twice. It could also be a parabola that opens downwards and it touches the x-axis twice. In this case, we have this algebraically. We have an s and a t that doesn't equal each other. There's another case where it's possible that we only have one solution. And this is when our vertex touches the x-axis. So let's say I had a parabola that opened up and it touched the x-axis at the vertex, or a parabola that opens down, once again, that touches at the x-axis. Algebraically speaking, if that was the case, our s is equal to the t. And what would happen? We have one solution. The x-intercept is also the vertex. Our third scenario is when we have zero solutions. It's possible that we have a parabola that opens up and starts above the y-axis, or a parabola that opens down but starts below the x-axis. In that case, we have zero solutions. All right, so let's look at this parabola. Y is equal to x plus 2 times x minus 4. What's the axis of symmetry? Now, we don't know exactly the axis of symmetry, but we do know what the x-intercepts are. And since we know that a parabola is equal on both sides, we know that right in the middle would be our axis of symmetry. We're going to find the x-intercepts, and we're going to find the midpoint. So looking at our first equation, y is equal to x plus 2 times x minus 4. So I'm going to set each bracket to equal 0. So my first answer, x plus 2 equals 0. X is equal to negative 2. Second option, we have x minus 4 is equal to 0, and so x is equal to positive 4. Right, now that I have these two answers, if I were to plot it out, I would have a point maybe around here and a point around here. Since we know that it's an equal distance from the x-intercept to the axis of symmetry, we're going to find the midpoint. So we're going to find the midpoint by adding these two values and dividing by 2. Right, so let's substitute it in. H is equal to negative 2 plus 4 divided by 2. H is equal to 1. So our axis of symmetry, we have x is equal to 1. Now, how can I find the coordinate of the vertex now? We talked about it the other day that if we have the axis of symmetry, we know that the axis of symmetry shares the same x value as the vertex. And if we know what that value is, we can substitute it into the equation to find our y. Okay, so substitute x is equal to h into the equation to find the y coordinate. Okay, we have y is equal to x plus 2, x minus 4, where we know that x is equal to 1. So now we have 1 plus 2 times 1 minus 4, and this is equal to 3 times negative 3. Y is equal to negative 9. Our vertex is going to be 1 and negative 9. So here's the summary. In order for us to find the axis of symmetry, we need the midpoint. For the midpoint, we're going to add our two x values for the x-intercept divided by 2. And for us to find the vertex, we have to substitute the h into our original equation to get the y-coordinate. Okay, in this example, we are given a function y is equal to negative 2 x minus 3 times x minus 1. Find the x-intercepts. I know that I'm going to make each of these brackets equal to 0. So the first bracket, we would have 3 and 0, and our second bracket would become 1 and 0. Find the opening direction. Opening direction is determined by the a. Our a in this case is a negative 2, so this is going to open down. Find the equation of the axis of symmetry. Our equation, we need to use our midpoint, and the equation is going to be our two x-intercepts divided by 2. So we have 4 divided by 2, and h is equal to 2. So our axis of symmetry, x is equal to 2. So with the vertex, we can now substitute it back into the original equation to find the other coordinate. So we have y is equal to negative 2, 2 minus 3 times 2 minus 1. Y is equal to negative 2 times negative 1 times positive 1. And we have y is equal to 2. So our vertex, 2, 2. The y-intercept, we know that all y-intercepts have a value of x is equal to 0. So I'm going to substitute it into the equation again. 0 minus 3 times 0 minus 1. Negative 2 times negative 3 times negative 1. Y is equal to negative 6. So the y-intercept, 0 and negative 6. We're going to sketch it onto the graph and label it with all the key features. Now, when we're sketching, it doesn't mean that it has to be perfect. We just want a rough location of where things are. Okay, so 3, 1, sorry, 0, 1, 0, and 3, 0. We know that this graph opens down. Y-intercept is at negative 6, and the vertex is at 0. Now, since this is our y-intercept, I know that on the other side here, we're going to have a point that's the mirror image. Okay, let's label what we have. We have the vertex at 2, 2. We have one x-intercept at 3, 0, another x-intercept at 1, 0, and a y-intercept at 0, -6. Let's join the dots to form a sketch of what the parabola looks like. We're also going to label the graph. Y is equal to -2 x minus 3 times x minus 1. Now pause the video and do the following slides with the practice questions. Here are the solutions to the pages where you are trying things on your own. And that is it for this part of the video.